Good evening. As I sit here, Comet ISON is speeding through the Sun's outer corona at a distance of 724,000 miles from the Sun's surface and is presently experiencing temperatures of 5,000 degrees Fahrenheit. ISON is thought to be a few miles in diameter and is travelling at 845,000 miles an hour. Most people in the astronomical community have their fingers crossed at the moment and are hoping that the comet will not disintegrate and will become a bright comet in the northeastern sky before sunrise from December the 2nd, with its tail pointing upwards from the horizon. Comet ISON has been closely monitored at the IRAM millimeter telescope in Spain by Israel Hamalo and NASA's spacecraft such as the Stereo mission. Observations are showing a rapid fading of the molecular emission lines between November the 21st and November the 25th by at least a factor of 20. Meanwhile, dust production seems to be enormous. What this could indicate is that the nucleus has broken up, releasing an enormous volume of dust while significantly reducing emission rates. Fragmentation or disruption of the nucleus has always been the highest risk factor for Comet ISON. Nevertheless, there is a good chance that Comet ISON will put on a show from December the 1st. Due to the slight pressure of the solar wind, all comets travel tail first as they move along their celestial path, and ISON is no exception. The comet will begin to fade as it moves away from the Sun, being at magnitude +5 on December the 7th, as it passes close to the star Yad Prior in the constellation of Ophiuchus. On December the 17th, ISON will move into the constellation of Hercules and will be visible in binoculars as a magnitude +6 for the star. On Boxing Day, December the 26th, the comet will be high in the eastern sky, moving above Hercules. It will now be in a dark sky, and again binoculars will show it really well, as it will shine at magnitude +6.6. On this day, Comet ISON will pass close to the Earth at a distance of 40 million miles. The comet will then move high overhead through the constellation of Draco, the Dragon, and on the 9th of January, ISON will lie a short distance away from the pole star in the tail of a little bear. Here's a minor. The comet will then have faded to magnitude +8 and will be easily visible in small telescopes. Not surprisingly, comet fever is sweeping the news headlines at the moment, and everyone wants to discuss comets and their place of origin in our solar system. In this program, I thought that I would talk about the little-known origin of some comets, Lazarus comets, within the main asteroid belt, as you are quite likely to be hearing a lot about these in the coming year. Every amateur astronomer is familiar with the asteroid belt located between the orbits of the planets Mars and Jupiter, which originates from the debris left over from the origin of our solar system 4.5 billion years ago. Today, we know much more about these minor planets, and astronomers have discovered a comet graveyard within the solar system's asteroid belt consisting of Lazarus comets that jump back to life after having been inactive for millions of years. Astronomers use a standard measure for determining the distances in our solar system based on the mean distance of the Earth from the Sun of 93.5 million miles, called the astronomical unit, which is reasonably accurate and quite well known. A glance at a chart of the solar system will show that the planets are divided into two groups. Mercury, Venus, the Earth and Mars are relatively small and close to the Sun. Then there is a wide gap, followed by the giant planets Jupiter and the rest. In the 17th century, it looked as though there were a missing planet between Mars and Jupiter. The German astronomer Johannes Kepler suspected that some such body might exist, and even wrote, "Between Mars and Jupiter, I put a planet." In 1772, the director of the Berlin Observatory, John Elliott Bode, drew attention to a strange law concerning planetary distances. It is still known as Bode's law, though it had been discovered some years earlier by another German, John Daniel Titius of Wittenberg. Take the numbers 0, 3, 6, 12, 24, 48, 96 and 192, each of which, apart from the first, has doubled its predecessor. Now add 4 to each, giving 4, 7, 10, 16, 28, 52, 196. Taking the Earth's distance from the Sun as 10, these figures give the distances of the remaining planets with remarkable accuracy when compared alongside their distances in astronomical units. Could this be a coincidence? When Bode first made the law known, Uranus still was undiscovered, but when it was found 9 years later by William Herschel in 1781, it fitted excellently into the scheme. The only trouble was that there appeared to be no planet corresponding to Bode's number 28 in the gap between Mars and Jupiter. If such a planet existed, it would certainly be faint, probably invisible without a telescope. If it had been even of the 5th magnitude, astronomers who had worked for years at compiling star catalogues, as Bode himself had done, would certainly have found it. It was reasonable to suppose that its orbit would not be far removed from the plane of the ecliptic, so that the planet would lie somewhere in the zodiac. In 1800, 6 astronomers assembled at the German town of Lilienthal, not many miles from Bremen. John Scroter, who was famous mainly because of his studies of the moon, had an observatory there and was a tireless worker in astronomy, so that Lilienthal was a good choice. The purpose of the meeting was to organise a systematic hunt for the missing planet. The astronomers formed an association which became known unofficially as the Celestial Police, and each undertook to study a different part of the zodiac, checking all the stars in an attempt to find an object which moved. The secretary of the police was a Hungarian, Baron Franz Axvar von Zach, who was director of the Seeberg Observatory near Gotha. A plan of this sort takes some time to bring into working order, and before the police could begin serious operations, they were forestalled. At Palermo, in the island of Sicily, the Italian astronomer Giuseppe Pesi was busy drawing up a star catalogue, and on January 1st, 1801, the first day of the new century, he picked up a point of light which behaved in most star-like manner. The object was a magnitude plus 8.7 and lying near the star de Nebula in the constellation of Leo, Lion. It moved appreciably from night to night, and Paisley thought that it must be a tailless comet. He was interested enough to write to von Zach, but unfortunately his letter took some time to arrive, and by the time von Zach received it, the strange moving body had been lost in the rays of the sun. Luckily, Paisley had made several observations of it, and Carl Friedrich Gauss, one of the greatest of German mathematicians, worked out an orbit and forecast its position so that it was rediscovered exactly a year after Paisley had first seen it. This time it was of magnitude plus 8.6 and lying on the border of the constellations Libra and Scorpio. It did indeed prove to be a new planet, and was named Ceres in honour of the patron goddess of Sicily. In one way, Ceres seemed to be disappointing. It was too dim to be seen with the naked eye, and was less than 500 miles across, which meant that it was much too small to be regarded as a proper planet. On the other hand, its distance from the Sun in 1802 was 3.7 astronomical units. Its orbit fitted in with Bode's law, and many astronomers considered that the solar system was at last complete. Today, Sirius can be seen in the constellation of Virgo in the southern sky before dawn, close to the star Delta, named Uva. However, it is visible in small telescopes. By observing this area of the sky over a few days, Sirius will be portrayed as a moving star-like object in the field of view. The celestial police had their doubts. It was at least possible, they considered, that other small planets might come to light, and they went ahead with their plans. In March 1802, Henrik Albers, one of the hunters, detected a second body slightly smaller than Ceres and moving at a slightly greater distance. Pallas, as it was named, was unusual in one respect. Its orbit was inclined to the ecliptic at an angle of 34 degrees, as against the 10.5 degrees for Ceres. In 1802, it was a magnitude +10 object in the constellation of Hercules, lying 3.8 astronomical units from the Sun. Olbers, a doctor by profession, was an amateur astronomer and had set up an observatory on the roof of his house in Bremen. His main work was in connection with comets, but he was also interested in the new planets, and he suggested that Ceres and Pallas might be the fragments of a large body which have broken up for some reason. In this case, there might be further pieces waiting to be discovered. In 1804, Carl Harding, Schroter's assistant at Lilienthal, found a third small planet, Juno, and in 1807 Olbers added a fourth, Vesta, which was the brightest of the four, though smaller than Ceres or Pallas. At times, Vesta may be seen with the naked eye as a faint speck of light. Together, the four became known as the minor planets or asteroids. Their orbits were very similar, apart from the sharper inclination of the path of Pallas. No more discoveries were made for some time. Schroter's observatory at Lilienthal was destroyed, and in 1815 the celestial police disbanded. There the matter rested until 1830, when another amateur, Karl Hennig, returned to it. Hennig was the postmaster at his native town of Dresden in Germany, and he felt convinced that there were more asteroids waiting to be discovered. Alone and unaided, he searched patiently for 15 years, and at last he was successful. In 1845, he found another asteroid named Astrea. Less than 2 years later, he detected number 6, Hebe. Now other astronomers started joining in the hunt. John Russell Hind in London added 2 more asteroids in 1847, Iris and Flora. A 9th, Metis, was discovered in 1849. There were 3 discoveries in 1850, 2 by the Italian astronomer Annibale de Gasperis, the director of the Capodimonte Observatory near Naples, and 1 by Hind. Since then, not a year has passed without the addition of many more asteroids. Over 3,000 have now been studied sufficiently for their orbits to be worked out, and many must remain undetected. There are thousands of asteroids scattered throughout the solar system. Many are thought to be shattered remnants of planetesimals, bodies with the young sun's solar nebula that never grew large enough to become planets. However, in this program, I want to concentrate on the majority of known asteroids that lie in the asteroid belt between the orbits of Mars and Jupiter. The main belt of asteroids contains more than 500,000 objects from 1 mile in diameter to about 500 miles. The traditional theory is that these objects are the remnants of a planet that never came to be, so we would not expect to find comets among the debris, since it implies that there is a large amount of water ice in and on the surface of many of the minor planets. Evidence for this is supported by evolutionary modelling. There then followed a series of remarkable discoveries. Over the last decade, 11 comets have been discovered in the region of the asteroid belt. The first of these was Comet Pizarro on July 24, 1979. Pizarro was reported in 1979 as minor planet named 1979 OW7, since its image in the photographic plate was completely stellar in appearance. The orbit remained entirely within the orbits of Mars and Jupiter, with an eccentricity of 0.165, which is typical of a minor planet in the asteroid belt. However, the images taken by Eric W. Eltz and Gordo Pizarro in 1996, when it was near perihelion, clearly show a cometary tail. Since this is not normal behaviour for asteroids, it was suspected that Eltz-Pizarro has a different, probably icy composition. The cometary nature of Eltz-Pizarro was first discovered in 1996, August 7th, when a linear dust feature was observed. Subsequently, around the next perihelion in November 2001, the cometary activity appeared again and persisted for 5 months. 3 years later, Comet 176P Linear was discovered by the Lincoln Near Earth Asteroid Research Linear Telescope in Socorro, New Mexico on September the 7th, 1999. Linear was discovered to be cometary on November the 26th, 2005 by Henry Hike and David Hewitt as part of the Howie Trails project using the Gemini North 8-meter 24-foot telescope on Mauna Kea, and it lies in the main asteroid belt. Since then, 8 more asteroid belt comets have been discovered, which include 238P Reed, 259P Gerard, P2010R2 Lascaria, P2012 F5 Gibbs, and P2012 Pan-STARRS. Now take a look at these images taken by the Hubble Space Telescope 8 weeks ago. Earlier this month, the Hubble science team released a press statement saying that astronomers using NASA's Hubble Space Telescope have identified what they can only describe as a never-before-seen weird and freakish object in the asteroid belt that looks like a rotating lawn sprinkler. Normal asteroids should appear simply as tiny points of light, but this asteroid, designated P2012P5, has 6 comet-like tails of dust radiating from it like spokes in a wheel. Because nothing like this has ever been seen before, astronomers are scratching their heads to find an adequate explanation for its out-of-this-world appearance. The lead investigator, David Hewitt of the University of California at Los Angeles, said, "Even more amazing is its tail structure changes dramatically in just 13 days as it belches out dust, but is also caught us by surprise. It's hard to believe we're looking at an asteroid." One interpretation is that the asteroid's rotation rate increased to the point where its surface started flying apart, ejecting dust in sporadic eruptions starting last spring. The team rules out a recent asteroid impact scenario because a lot of dust will be blasted into space all at once, whereas P5 has ejected dust for at least 5 months. When Hubble returned to the asteroid on September the 23rd, his appearance had totally changed. It looked as if the entire structure had swung around. "We were completely knocked out," Hewitt said. This is further evidence that astronomers have discovered a comet graveyard within the solar system's asteroid belt, consisting of comets that could jump back to life after having been inactive for millions of years. Astronomers from the University of Antioquia have now named these Lazarus comets after Saint Lazarus of Bethany, who was the subject of a prominent miracle attributed to Jesus in the Gospel of John, in which Jesus restores him to life 4 days after his death. Comets are traditionally thought to come from 2 much further locations, the Kuiper Belt and the Oort cloud, trans-Neptunian objects that lie at extreme distances from the Sun. Comet ISON, now on prominent display, is a long-period comet that is known to originate from the Oort cloud, while short-period comets originate from the Kuiper Belt. Since the discovery of Lazarus comets, astronomers have been debating just how much water ice the main asteroids contain, and there are 2 schools of thought. There are those who believe there is a significant quantity of water ice in the crust and mantles of asteroids, which is supported by evolutionary modelling, while others consider that the structure of the minor planets are porous, rather like pumice stone, resulting in the same density of the materials. The minor planet Ceres is a good example. Ceres is about 400 miles in diameter, which makes it the largest object in the asteroid belt. The surface area is equal to the land area of India, and its mass is about a third of the combined mass of the entire asteroid belt combined, which is sufficient to give it a merely spherical shape. In contrast, other large asteroids such as Pallas and Juno are known to be somewhat irregular in shape. High-resolution ultraviolet Hubble Space Telescope images taken in 1995 show a dark spot on its surface which was nicknamed Paisley in honour of the discoverer of Ceres, which is thought to be a crater. Later, near-Earth near-infrared images with a high resolution taken over a whole rotation with the Keck telescope showed several bright and dark features moving with series of rotation. Two dark features had circular shapes and are presumably craters, one of which was observed to have a bright central region. These last observations determined that the North Polar Sirius points in the direction of the constellation of Draco, which means that Sirius' axial tilt is very small, about 3 degrees. There are indications that Sirius may have a tenuous atmosphere and water frost on its surface. Surface water ice is unstable at distances less than 5 astronomical units from the Sun, so it is expected to sublime if it is exposed directly to sunlight. Water ice can migrate from the deep layers of Sirius to the surface, but will escape in a very short time. As a result, it is difficult to detect water vapour. It may be possible to detect escaping water from the surroundings of a fresh impact crater or from cracks in the subsurface layers of Sirius. However, ultraviolet observations by the International Ultraviolet Explorer spacecraft detected significant amounts of hydrogen near the North Pole. We know that the surface of Sirius is relatively warm. The maximum temperature with the Sun overhead is estimated to be about minus 38 degrees centigrade, and observations of Sirius by astronomers using the Keck telescope in 2002 indicate that it consists of a rocky core overlain with an icy mantle. This is where astronomers have a difference of opinion. Some believe that the icy mantle is about 62 miles thick and contains 125 million cubic miles of water, which is more than the amount of fresh water here on Earth, a result that is supported by evolutionary modelling. On the other hand, some astronomers believe that the shape and dimension of Sirius may be explained by an interior that is porous. The presence of a layer of rock on top of ice would be gravitationally unstable. If any of the rock deposits sank into a layer of ice, salt deposits would be formed. Such deposits have not been detected so far, so it is possible that Sirius does not contain a large ice shell at all, but was instead formed from low-density asteroids with a water component. It is therefore advantageous to be able to obtain rock samples from an asteroid and examine this in some detail. Since the discovery of Lazarus comets, meteorite hunters have discovered space rocks from Vesta-type asteroids known as HED meteorites, which stands for howardite, eutherite and diogenite. These acrondrites come from a parent body that has experienced extensive igneous processing, similar to the magma-type rocks found here on Earth, and for this reason they are closely resembled terrestrial igneous rocks. That's rocks that were once molten and have since solidified. These are all thought to have originated from the crust of the asteroid Vesta. Their crystallization ages have been determined to be 4.5 billion years from radioisotopes, which happens to be the age of our solar system. Astronomers believe that a huge impact on Vesta by an asteroid ejected debris, creating small 6-mile diameter Vesta-type asteroids. This event is thought to have happened 1 billion years ago. While investigating the HED meteorites, scientists became excited by the idea of sending a spacecraft out to the asteroid belt to take a closer look at the minor planets themselves. On September the 27th, 2007, NASA launched the Dawn spacecraft to study the two largest objects in the asteroid belt, Vesta and Ceres. Dawn was the first spacecraft to visit Vesta, entering orbit in July 16, 2011, and it is the first NASA mission to use ion propulsion. Previous missions had used conventional drives, such as the Voyager spacecraft, which were restricted to flyby missions. With its arrays fully extended, Dawn is 65 feet long and carries 3 key scientific instruments. It is a framing camera, of 20mm aperture for taking high resolution images of the surface features of Vesta and Ceres from orbit, a visual and infrared spectrometer, which is a modification of the visible and infrared thermal imaging spectrometer used on the Rosetta and Venus Express spacecraft, and a gamma ray and neutron detector, GRAND. This instrument is based on similar instruments flown on the Lunar Prospector and Mars Odyssey space missions. The instrument is used to measure the abundances of the major rock-forming elements: oxygen, magnesium, aluminum, silicon, calcium, titanium and iron on Vesta and Ceres. The first minor planet to be visited by dawn was Vesta. Vesta is the brightest asteroid visible from the Earth and is one of the largest minor planets in the solar system, with a mean diameter of 326 miles. It is the second most massive asteroid after the dwarf planet Ceres and comprises an estimated 9% of the total mass of the asteroid belt. Its maximum distance from the Sun is slightly farther than the minimum distance of Ceres from the Sun, though its orbit lies entirely within that of Ceres. Vesta is also the last remaining rocky protoplanet of the kind that formed the planets Mercury, Venus, Earth and Mars 4.5 billion years ago. Prior to the arrival of the NASA's Dawn spacecraft, some surface features had already been resolved using the Hubble Space Telescope and the Keck Observatory. Images and science observations returned by the Dawn spacecraft from the summer of 2011 have confirmed that Vesta lost 1% of its mass less than 1 billion years ago in a collision that left an enormous crater occupying much of its southern hemisphere. This impact area is the most prominent of the surface features on Vesta, which is an enormous crater 314 miles in diameter, centred near the South Pole. The Dawn science team has named it Ray Silvia, after the mother of Romulus and Remus and a mythical Vestal Virgin. Its width is 90% of the diameter of Vesta. The floor of this crater is about 8 miles below, and its rim rises 3 to 8 miles above the surrounding terrain, with a total surface area of about 16 miles. The central peak rises 14 miles above the lowest measured part of the crater floor, and the highest measured part of the crater rim is 20 miles above the crater floor. The Snowman craters are an informal name given to a group of 3 adjacent craters in Vesta's northern hemisphere. Their official names, from largest to smallest, are Marcia, Calpurnia and Municia. The majority of the equatorial region of Vesta is sculpted by a series of concentric troughs, such as Devalia Fossa, which is 6 to 12 miles wide and 290 miles long, which encircles the equator. A second series inclined to the equator, such as Saturnalia Fossa, are 25 miles wide and 230 miles long, which are found further north. These are thought to be the large-scale fractures resulting from the impacts that created Rhea Silvia and Venetia craters. They are some of the longest chasms in the solar system. The troughs may have been formed when another asteroid collided with Vesta 1 billion years ago. NASA's Dawn spacecraft is currently en route to Ceres and is expected to arrive there in February 2015, when it will fire its thrusters and enter into orbit around the asteroid. Dawn will then return images of the whole surface of Ceres and make important scientific observations which will help scientists answer some intriguing questions. In particular, whether Ceres is a huge ice ball in the heart of the asteroid belt, as some astronomers suggest. The minor planets are far more interesting today than ever before, and I suspect we'll be hearing more about Lazarus comets in the near future, as the so-called celestial police are just as busy today unearthing their mysteries. That's all we have time for this month. Thank you for watching. Until we come back next year, in January, I'd like to wish you all a very happy Yuletide and a prosperous New Year. Goodbye for now. December the 7th, as it passes close to the star Yad Prior in the constellation of Ophiuchus. On December the 17th, ISON will move into the constellation of Hercules and will be visible in binoculars as a magnitude +6 for the star. On Boxing Day, December the 26th, the comet will be high in the eastern sky, moving above Hercules. It will now be in a dark sky, and again binoculars will show it really well, as it will shine at magnitude +6.6. On this day, Comet ISON will pass close to the Earth at a distance of 40 million miles. The comet will then move high overhead through the constellation of Draco, the Dragon, and on the 9th of January, ISON will lie a short distance away from the pole star in the tail of a little bear. Here's the minor. The comet will then have faded to magnitude +8 and will be easily visible in small telescopes. Not surprisingly, comet fever is sweeping the news headlines at the moment, and everyone wants to discuss comets and their. A glance at a chart of the solar system will show that the planets are divided into two groups. Mercury, Venus, the Earth and Mars are relatively small and close to the Sun. Then there is a wide gap, followed by the giant planets Jupiter and the rest. In the 17th century, it looked as though there were a missing planet between Mars and Jupiter. The German astronomer John Kepler suspected that some such body might exist, and even wrote, "Between Mars and Jupiter, I put a planet." In 1772, the director of the Berlin Observatory, John Elliott Bode, drew attention to a strange law concerning planetary distances. It is still known as Bode's law, though it had been discovered some years earlier by another German, John Daniel Titius of Wittenberg. Take the numbers 0, 3, 6, 12, 24, 48, 96 and 109. Good evening. As I sit here, Comet ISON is speeding through the Sun's outer corona at a distance of 724,000 miles from the Sun's surface and is presently experiencing temperatures of 5,000 degrees Fahrenheit. ISON is thought to be a few miles in diameter and is travelling at 845,000 miles an hour. Most people in the astronomical community have their fingers crossed at the moment and are hoping that the comet will not disintegrate and will become a bright comet in the northeastern sky before sunrise from December the 2nd, with its tail pointing upwards from the horizon. Comet ISON has been closely monitored at the IRAM millimeter telescope in Spain by Israel Hamalo and NASA's spacecraft such as the Stereo Mission. Observations are showing a rapid fading of the molecular emission lines between November the 21st and November the 25th by at least a factor of 20. Meanwhile, dust production seems to be enormous. What this could indicate is that the nucleus has broken up, releasing an enormous volume of dust while significantly reducing emission rates. Fragmentation or disruption of the nucleus has always been the highest risk factor for Comet ISON. Nevertheless, there is a good chance that Comet ISON will put on a show from December the 1st. Due to the slight pressure of the solar wind, all comets travel tail first as they move along their celestial path, and ISON is no exception. The comet will begin to fade as it moves away from the Sun, being at magnitude +5 and place of origin in our solar system. In this program, I thought that I would talk about the little-known origin of some comets, Lazarus comets, within the main asteroid belt, as you are quite likely to be hearing a lot about these in the coming year. Every amateur astronomer is familiar with the asteroid belt located between the orbits of the planets Mars and Jupiter, which originates from the debris left over from the origin of our solar system 4.5 billion years ago. Today we know much more about these minor planets, and astronomers have discovered a comet graveyard within the solar system's asteroid belt consisting of Lazarus comets that jump back to life after having been inactive for millions of years. Astronomers use a standard measure for determining the distances in our solar system based on the mean distance of the Earth from the Sun of 93.5 million miles, called the astronomical unit, which is reasonably accurate and quite well known.